this video we will look at partial fractions. Suppose we have 2 over x plus 3 and we will add to it 3 over x plus 5. This is just a simple process of adding fractions together, and we know that the result would be 2 times x plus 5 plus 3 times x plus 3 all over x plus 3 times x plus 5. The numerator becomes 2x plus 10 plus 3x plus 9 all over x squared plus 8x plus 15, giving us 5x plus 19 over x squared plus 8x plus 15. What you'll note is that this rational function is of the form linear over quadratic. That is, the numerator is a linear function and the denominator is a quadratic function. Another important result to note before looking at partial fractions is that if I have a quadratic ax squared plus bx plus c, and I'm told that this is identical to another quadratic, in this case uppercase ax squared plus bx plus c, I can infer that the coefficients are equal. That is, lowercase a equals uppercase a, b equals b, and c equals c. This, in fact, is true for any polynomial, and the proof of it is not so difficult. To give you an example on how you would start the proof, if this is true for all values of x, it is true then for x equal to 0. On the left we're just left with c, and on the right we're just left with c, and so we have c equals c. With these two ideas, we are now able to look at partial fractions. Let's have a look at an example. Using partial fractions, simplify this so that the quadratic denominator is removed. Well, this is of the form linear over quadratic, and so we know that we can use partial fractions here. But we'll also note that this can be written as 5x plus 7 over x plus 1 times x plus 2. Now, we can split this up into a over x plus 1 plus b over x plus 2. What we'll do next is we bring these two back together. Adding these fractions gives us a times x plus 2 plus b times x plus 1 all over x plus 1 times x plus 2. Expanding the numerator on the right gives us a plus bx in total, and then 2a plus b as the constant, all over x plus 1 times x plus 2. The denominators here are the same, and in fact the numerators then must be the same also. You can think about it like this if you prefer. We can cancel the denominators and we're just left with the numerators, which we're told is equal. So on the left we have 5x plus 7 must be the same as a plus bx plus 2a plus b. You can see highlighted in red and blue are the coefficients. On the left we have a linear function, and on the right we have a linear function. We're in the position to say, using our second idea of the slides, that 5 must be identical to a plus b, and 7 must be identical to 2a plus b. So we have to solve the following system. That is, a plus b equals 5, and 2a plus b equals 7. This isn't too difficult to solve. The b's are already in a position to be cancelled. By subtracting these equations, I'm left with a equal to 2, because 2a minus a is a, b's cancel, and we have 7 minus 5. Putting this back into the first equation, that is, putting it into a plus b equals 5, gives us b must equal 3. And so we have the result, that 5x plus 7 over x squared plus 3x plus 2 must equal 2 over x plus 1 plus 3 over x plus 2. Here's an example I would like you to try. Pause the video and try this one. Resume when you're ready to see the answer. Using partial fractions, simplify this so that the quadratic denominator is removed. 2x plus 15 over x squared plus 15x plus 50. Well, the denominator is equal to x plus 10 times x plus 5. And we can see that this can be split into a over x plus 10 plus b over x plus 5. Bringing these back together, and on the right we have ax plus 5a plus bx plus 10b over x plus 10 times x plus 5. Comparing the linear functions, after tidying up of course, in the numerator will give us the answer. In the numerator we have a plus bx and 5a plus 10b. So we are left with 2x plus 15 is identical to a plus bx plus 5a plus 10b. And so we have that a plus b must be 2 and 5a plus 10b must be 15. This is a linear system to solve, but you can see the answer almost immediately. Clearly, if a equals b equals 1, we have the result. 1 plus 1 is 2, and 5 plus 10 is 15. So we have our answer. That is 2x plus 15 over x squared plus 15x plus 50 equals 1 over x plus 10 plus 1 over x plus 5. That's all for this video.